In this video, we demonstrate how you can monitor your IBM integration bus applications using nJAMS to improve your insights into the system. We start with an introduction into the example application used over the whole demonstration. The message flow you can see within the toolkit is the first message flow in the processing of an order, the so-called order create request flow. The basic order information is received on an input queue, and by using the aggregate control and aggregate request nodes, the message is distributed to the backend system to retrieve the product, the price, and the customer data relevant to this order. Each message, enriched with the product, the price, or the customer details, is now returned to be processed by the order create response flow, which is now opened. The messages arrive on an input queue and are accumulated by the use of the aggregate reply node. Once all 4 distributed messages have been received by this node, the combined message is forwarded to a compute node for final reassembly, before being transformed to the final output format via an XSLT invoked within the XSL transform node. Using the utility program rfhutil, we can easily put the input message to the input queue. You can see the input message on the screen is a basic XML message comprising the order and the customer numbers, as well as the order line data showing the item code and the quantity required. We are now inside the nJAMS instance to which the IIB client is connected. On the left side, you see a multi-level hierarchy that allows you to navigate through all the recorded flow executions. This hierarchy is formed by the integration node, the integration servers, the host name, the name of the application, and a list of message flows and subflows. All these entries are currently grayed out because we did not receive any monitoring data yet. Expanding the tree, we find the just introduced message flows order create request and order create response from our sample application. When a message flow is selected from the tree, the graphical interpretation of the message flow is displayed in the process diagram box on the right side. Here we find nodes and the connections as we have seen them before in the message flow editor of the developer's toolkit. In this process diagram, we see some nodes marked with a yellow bulb above. This indicates that tracing is enabled on this particular node. You can simply enable or disable tracing by a single click on the bulb after selecting the node. With tracing enabled, the nJAMS clients connect more details of a node during process execution. And of course, we can also see the corresponding process diagrams for all other monitored message flows like order create response from our sample application. In the background, we will now trigger a message flow by placing a message on the input queue using the rfhutil. After the message flow has been executed, results will appear in the result list in the middle of the screen. Since in this nJAMS instance rules are defined which analyze the incoming monitoring data, you now see a notification in the lower right corner that the message flow instance has exceeded a configured threshold. We will demo this configuration later. And after refreshing the result list, you now see the corresponding message flow instance in the result list located in the middle of the screen. If the message instance contains attributes, they will be displayed immediately. In this case, you can see the customer and message ID. You can also see the start time, the execution time, and the status for each result list entry. The envelope icon indicates that trace data is stored for this message flow instance. You could use the filter functions above the result list or the search bar to filter your results. If you now select one of the instances from the result list, you will see additional information in the process diagram, such as the execution path represented by green arrows, the status, and the execution time of each node. The envelope icon shows on which node trace data was stored. The collected trace data can be reviewed by selecting the node and navigate to the input and output section. Here we find an XML representation of the node's input and output data. As mentioned, you can see the execution time of each activity. This can be toggled by clicking here. And of course, data is also recorded for the order create response message flow. When we select the message flow in the tree, the result list changes. Trace points were also defined on this message flow, so input and output data are also recorded here. This can help you understand what was consumed and produced by a node, in this example in XML referring to the customer and the order. In the navigation bar left to your user's name, you will find the so-called notification center. The last notifications are always displayed here. In this instance, rules are defined which create notifications if a message flow execution has exceeded a configured threshold. That's why you can see all these notifications here. Rules like this can be created and managed under the menu item Rules. When a rule is matched, many different actions can be fired. For example, notifications or emails or even REST API calls that send messages to Slack or Teams. This rule, for instance, sends an email and triggers an internal nJAMS notification every time when the duration of a message flow named order create response exceeds 30 milliseconds. This is a pretty simple example leveraging the rule engine, but you can also model much more complex rules. Another very important thing to mention is correlation. Using correlation log IDs. Starting from each message flow instance, we can see which other message flow instances were involved in processing the data. By clicking the green folded icon under a message flow instance, a list of correlating executions is displayed. As you can see here, the order create request involved 4 order create response message flow instances.